Hello everyone, welcome back. This is Mr. Koval, and in this video I'm going to show you how to use your orbital diagram to do electron configurations. And so the question is, how do you put the electrons into the atom? And so the orbital diagram shows us the structure that we need to use to put the electrons into different levels and sublevels and orbitals. Okay, so let's get into this. So on this orbital diagram, I'm going to add a few notes. So you may want to put the notes on there as well. So the first thing, there's two principles and one rule that we need to follow when we're adding electrons to our orbital diagram. So the number of first rule is called the Aufbau principle, or let me write this down. So I'll write it here. So number one, the Aufbau principle. I'll just do P for principle. What does that say? Basically, the thing you want to remember is that electrons are lazy. And what do we mean by that? We mean that they want to have the lowest energy possible. So let's write that down. So they want to use the least amount of energy. Want to use least amount of energy, okay, possible. Okay, what does that mean? That means that we're going to fill our orbital diagram from the bottom to the top, from the bottom to the top. Okay, so here you can see on the side here is energy. So the arrow is going up. So here we have low energy, and here we're having high energy. So as you go up, the energy levels get higher. So where is the nucleus in all of this? The nucleus is down here. So let's put a nucleus down there. So as electrons are being put into different places, the lower the energy, the closer the electron is to the nucleus. Okay. So we're going to fill in electrons, and this makes sense because electrons are negative. The nucleus has positive protons, and so it makes sense that the electrons would want to be close to the nucleus as possible. So here we would start at the what is called the 1s orbital, and here we're at the energy levels. So this n equals 1 represents this dark band here. That's energy level number 1. Energy level number 2 is this dark band here, and so on. So these dark bands are the energy levels. And you can see that each energy level is broken up into sublevels. So this energy level, n equals 1, only has one sublevel, the 1s. And this energy level has two sublevels, the 2s and the 2p. The third energy level has the 3 energy levels. So you'll see the 3s, 3p, and the 3d is up here. So that's energy levels. And then the 4n, the n equals 4, has 4 sublevels. You can see 1, 2, 3, and 4. So that's you want to look at that and keep that straight. All right, so notice that the levels and sublevels differ in energy. So we're going to add electrons starting here, and we're going to, when this level gets filled up, then we're going to add electrons to the next level if we've got them. And we're going to keep adding electrons to each level until we run out of electrons for that particular atom. And then we stop. Okay, so that's the Aufbau principle. The second principle that we want to keep in mind is called the Pauli exclusion principle, right? So here, I'll write that here. So 2 is, just say Pauli exclusion, P for principle. And basically that is saying that there's only 2 electrons per orbital, right? So 2 electrons per orbital. So 2 electrons per orbital. And that means that and they have to have opposite spins, right? So 1 electron has a spin up, 1 electron has spin down. So one electron spin up, and we represent that by an up arrow, and 1 electron spin down, and we represent that by a down arrow. And so you can only have 2 electrons in there because each electron has to have opposite spin. So if you put 1 electron in, it'll be 1 spin, and then when you add a second electron to that orbital, it will have an opposite spin, and that's all that's allowed. You can't have electrons in the same orbital with the same spin. So that means you can only have 2 electrons max. So I'll do that up here. So therefore, I'll do it right here. So spin up, or spin down and spin up. So therefore, 2 electrons max. 2 electrons max. Okay. So that is the second principle. And finally, the third is a rule. It's called Hund's rule. So we'll do 3 there. Hund's rule. And Hund's rule says basically that if you are adding electrons to orbitals of the same energy, then you need to add electron to 1 orbital at a time before you pair them up. So you put 1 electron in each orbital first, and then once all the orbitals of that energy level, or that have that same energy, once they have 1 electron and you have more electrons, you can start to pair them up. So what is that? In short, we want to say put 1 electron per orbital first, then double up or pair them up. Okay, so let me also point out here with Aufbau principle. So when we're doing our orbital diagram, we want to mark out where do we start and where do we end. So if we're going to fill this in, Aufbau principle means we're going to start here at the 1s and then fill that up. Go to the 2s, and then we're going to go to the 2s, and then from the 2s to 2p, which is the next higher. And then once we fill in the 2p, this is your, again, remember these orbitals here, you have 3 different orbitals, right? So remember, this is the px, pz, py. Let me use a different color here. So this is your px, py, pz, Again, this is px, py, pz, and so on. So we have those three orbitals, right? So when you fill in each of these orbitals, once this level is filled in, then you're going to go to the next higher level, which is the 1s. And then when that's filled, you're going to go to the 3p sublevel, fill in those 3p orbitals. And then you're going to go to the 4s, and then to the 3D. And then once the 3D, notice that the 3D is next in energy before the 4p. So you're going to go from 4s to 3D. Then once the 3D is filled, then you go to the 4p. And then from the 4p to the 5s, 5s to 4D, 4D to 5p, 5p to 6s, 6s to 4f. Now we're going to the 4f. And then we want to go to the 5D. And then from the 5D to the 6p, 6p to the 7s. And then from the 7s to the 5f, 5f to 6D, 6D to 7p, and so on. So that is following the Aufbau principle. Okay, so now that we have this kind of marked up and with our notes on there, we can use this to figure out what the electron configuration is for a certain element. And again, the electron configuration for an element is just this structure right here. How are the electrons put into the atom? That is what we refer to as electron configuration. So this orbital diagram gives us the electron configuration. And then we write that out in a way that I'm going to show in a moment. So let's start with an example. So we have, let's start with fluorine. Let's do fluorine. So let's write out the electron configuration for fluorine. So here. So we first need to know how many electrons that fluorine has. So if you look on your periodic table, you look for fluorine, and you'll see that fluorine is number 9 on the periodic table. That means it has 9 valence electrons, or I should say not valence electrons, 9 electrons. It's in group 7, so it has 7 valence electrons. So 9 electrons total. We need to know the total electrons so we could put those into our orbital diagram and then write out the electron configuration. So we know that it has 9 electrons because we're assuming a neutral atom. So the atomic number of fluorine is number 9. That means it has 9 protons. And if we have a neutral atom, that means we have the same number of electrons that are going to balance the charge of the proton. So now that we know how many electrons we have for our atom, we're going to fill those in according to the rules. So notice first Aufbau principle. So we're going to start from the bottom and we're going to fill in our electrons. And the way we do that is we write them as arrows. Okay, so we're going to start here because this is the lowest energy level and we have 9 electrons. So we're going to have to put electrons into the first orbital. So each one of these little boxes is an orbital. So the first orbital, this sublevel, the S sublevel, only has 1 orbital. You can see that all the S sublevels only have 1 S orbital. You can see that the P sublevels all have 3 P orbitals. The D sublevels all have 5 D orbitals, and the F sublevel has 7. So we're going to work our way up. So we're going to put 2 electrons, spin up, spin down. So there's 2 electrons. We're obeying the Pauli exclusion principle. So making sure that the electrons have opposite spin and we only have 2 electrons in our orbital. And we're starting at the lowest energy level following the Aufbau principle. So there's 2 electrons. We have 7 more. So now we're going to go to the next higher level. And so that's the 2s, and we're going to fill that in. So that orbital is going to be filled in with 2 electrons, spin up and spin down. Now that's 4 electrons, and we have 5 more to go. So those 5 electrons, we're going to start to fill in the 3p orbitals. So here we have 3 equal energy orbitals, the px, py, pz. So we're going to follow Hund's rule. So we're going to put 1 electron in each of those, and they have to be the same spin. So the first one is spin up, 2px. The 2py gets an electron, that's going to be spin up. And the third p orbital gets an electron, that's going to be spin up. So they're all spin up 1 electron at a time, and that is 3 more. So that's going to be 4 and 3, that's 7. So we have 7 electrons accounted for. We have 9 total. We need to put 2 more in. So these orbitals are not filled up, so we cannot go to the next energy level. We need to fill these up first. So those 2 electrons are going to need to be paired up. So we're going to have to put an electron there, spin down. So we're following the Pauli exclusion principle. So that electron has to be spin down. And the last electron goes in, spin down. And so this is what the orbital diagram for fluorine is going to look like. And when we write the electron configuration, all we do is we write from the bottom up. So here. So then let's write this down. So the electron configuration. So the electron configuration for fluorine. That's F is, we have 9 electrons. So here we go. So that's going to be, start down here. So we have 1s, start with the 1s. We have 2 electrons in the 1s, so that's going to be 1s2. We'd write a superscript for that. Then the next one is going to be the 2s, so we write 2s. And we got 2 electrons in there, so that's going to be superscript 2. And then we have the 2p, so the next higher one is the 2p. And we have 5 total electrons in there, so we just group them together as a 5. And so that's going to be the electron configuration for fluorine. And so that's how it's done. You put the electrons into the orbital diagram first, and following the rules and the principles. And then once you've got them all in there, you just go from the bottom. You start at the bottom and work your way up, writing the energy level and the sub-level at each as you go up until you get to the end. Okay, so let's do a few more examples. In my next video, I'll go over some examples using this orbital diagram. Thanks for joining me. I hope this is helpful. If you like my videos, please like, share, subscribe to my channel. Hit that notification bell. Let me know what you think in the comments. Ask me some questions. And thanks for joining me, and have a great day.